So I've been a developer for a while. I'll also kind of my own personal tragedy is that I never figured out where I belong in the kind of product versus development spectrum. So whenever I was coding, I couldn't kind of stop thinking about the why and the use cases. And then I gravitated towards PMing, and then I hated it because I missed coding. So I came back to coding and so forth and so on until I kind of managed to somehow piece together positions that allowed me to combine the two. And I think this also kind of made me a little bit more perceptive and kind of made me notice even more this gap in how we write code. And this is what I want to start by talking to you about. And to illustrate that, make it a little bit less abstract, I want to take an example of a story from a member of my team and maybe get your read on that as well. So this is the story of a developer on my team. I'm going to call him Bill just for the sake of this discussion. And Bill has been charged with a task that you all are very familiar with, basically developing a feature and introducing it into the code base. Now, it used to be that, that task was pretty straightforward. Like I remember back in the days, not to sound too old, but when we were coding a feature, it was about, getting the coding done and then packaging up real nice, going to the guys across the hall at the QA department and handing them that feature so that they can test it, and eventually it would find its way into production. And that's where our involvement ended, right? And it's no longer like that. And today, developers know a lot about kind of how to test the feature, sometimes even how to deploy it. So Bill's involvement in getting this feature out all the way into production is kind of very deep. He's very well, he's a great developer. He knows all about how to write unit tests, how to write integration tests when he needs it. He knows about Helm files and deployment and all sorts of things that have to do with maybe DevOps a little bit. And at the same time, when things already hit production, there is kind of an open question about what happens next. Sorry, just 1 second. For some reason, got stuck.
Yeah, you're looking good.
Now let's me do something like this. Okay.
There you go.
So there is some question about what happens next. So what happens the minute after Bill deployed to production, and what should he do? And this is where I want to pause for a second and ask you guys, please, in the chat, or if you want to quickly unmute yourself and kind of say what you think. What do you think, Bill, the developer in my team, who's such a great developer that knows all about kind of the GitOps process, what should he do the minute after he deploys? What are your thoughts on that? What would you do the minute after you deployed a really important feature into production? Check logs. That's interesting. Yeah.
And I did fix it so you can unmute yourself if you wish, folks.
Yeah. And validate. Yeah, that's a great suggestion. I wish more developers would check logs and validate after they deploy. What do you think mostly happens? Like 99 enable PagerDuty. That's a good one. What do you think happens 99% of the time when developers push their feature into production? What do they do next? Well, all of these are really great suggestions, but they don't do any of that. And what I have seen across many development teams is that what happens next is essentially nothing. I'm not even talking about all of these great suggestions like metrics and logs. Bill would normally not even check if his function is working, that his code is being called. And I really like this comment about move to new development, thinking done and dusted, because yeah, that's exactly kind of a very accurate description about what happens. So what I expected Bill to do was to ask questions. This seemed so trivial to me that I was surprised it didn't exist. Did my code work well? Is anybody using it? Did it change anything? Did it make life better? I just rolled out this new data access layer update. Are things working better now? Some very trivial ideas about how can we validate our work, check it, get some kind of feedback about how it works. But instead, just like Narendra suggested, we just move on to the next task. And I have to admit that I'm a part of the problem, or when I took on the role of the product manager, I was a part of the problem, because it's not just the developer. It's kind of like the entire engineering organization is very forward-looking. Like when I was a product manager, when a developer came up to me and said, I've just completed this amazing feature, and my thought would be to tell him not, okay, what do you know about it? Does it work? What kind of metrics do you have? It would be, what about the next feature? Because I am measured on how fast I advance the roadmap, right? So there is nothing inherent in the organizational culture that actually encourages Bill or other developers to take this very irregular action of checking logs or metrics or all of the amazing suggestions that you guys had. However, I went back to the basics and I kind of looked at this by now completely overused example of the DevOps loop. And immediately something jumped out at me as completely odd in this diagram. And this is like the first diagram you see when you search for continuous feedback on Google Images. And I think the flaw exists in most of the diagrams that I saw. So yeah, monitoring needs to be a part of the definition of done. That's a really great comment. And we'll talk about that in a sec. But what do you find odd about this? Is there anything that jumps out at you in this diagram that we're all used to seeing by now? Where is the user? Continuous feedback only happens after. Yeah, there's a lot of things wrong with this diagram, if you ask me. Like a lot of things happen here, like everywhere all at once and so on. But if you notice, all of the different stages here have amazing tools assigned to them, except for continuous feedback, which for some reason has Salesforce assigned to it. And I have to admit, by now I've been given this talk, multiple times. I should hunt down the guy who created this diagram and ask him what was the thought behind that. But Salesforce is the only tool that appears here for continuous feedback. But there is a clear connection between deploying to production, operating, and all of that, and taking that knowledge back to planning, back to building, understanding what just happened. What is my code doing as a developer? And this made me think. This made me think about feedback in general, because we get a lot of feedback when we code. We get a lot of feedback when we test, or well, not exactly a lot. We get some feedback, let's say functional feedback when we test, and almost no feedback from the production runtime. And I thought to myself, well, if only we had access to objective data, instant objective data about our code, no matter what we were doing, it was always like one click. Yeah, now we know everything that we need to know about this code. And that's a perfect segue to talk about OpenTelemetry. So OpenTelemetry is important, but it's not because it's such a revolutionary technology or some great leap forward in development. In fact, it's a rehash or a reiteration of things we did already. It's kind of a combination or merged together of two previous standards, OpenTrace and OpenCensus. There is no great kind of technological leap here. The reason OpenTelemetry is extremely important is because everybody agrees on it. And that hadn't happened in a while, at least in the observability space. So suddenly, instead of having this fragmented landscape of so many kind of proprietary standards or even open standards that vary between each other, there is one standard that finally is in agreement. And that makes it very easy for platforms to extend support for it. So if I'm writing a library or a framework today in Java, it's very clear that if I need to support one standard, it would be OpenTelemetry. And that, coupled with the fact that it's open and not kind of like a vendor-specific standard that I need to kind of backwards engineer to understand how it works, is a big game changer, because now all of a sudden, as an end user, as a Java developer, it's already there, like batteries included, right? It's all of the frameworks and the tools that I'm using, 99% of them are already going to support it. And that's a big deal. It means that to get from zero data about what my code is doing to getting almost too much data, and we'll see that in a sec when we look at the code, is almost trivial. But what do we do with all of this data? And today I'm going to talk about two use cases. One of them will touch briefly on metrics, but I'll talk a little bit about tracing and why tracing can help me as Bill or as a developer that wants to kind of understand what my code is doing and whether I did good and when I pushed my feature into the code base. Tracing can really give me a new set of tools to do that. So how many people here, and maybe we can do kind of like a raise of hands thing, so just that I know kind of how deep to go into it. How many people here are already familiar with tracing, or kind of are familiar with the concept? Like if you are, you can do kind of like a raise hand within a Zoom. So I see one. Great. So there's a potential here, because it looks like most people did not yet, or some of you did, but some of you definitely did not have a chance to play around with tracing. So tracing is essentially a way to understand what happened during a request lifecycle. Since we're talking about OpenTelemetry, it's also distributed tracing. So that means that we can extend that kind of understanding across multiple microservices if needed. But at the very basic level, it tells us what happened when a certain request happened. So let's say we called, we're going to take the pet clinic example from Spring Boot. So let's say we call the get owners API endpoint. We have basically the request hit Java Spring, then it used in maybe JDBC to get some information from a database. Maybe there's an external HTTP call, and eventually the request gets back to the user. And we can even go more granular than that, and we can define what we call spans. And spans are basically activities or scopes within that trace that we can track. So how long did it take to get the HTTP request? How long did it take to render? How long did it take to do the validations? We can keep track of each of these segments within the request. until we have this kind of a request anatomy or slice. And this is what it looks like. So we can kind of, because we have this amazing support for OpenTelemetry and we have all of these libraries that already support it, as Bill, when we look at what our code was doing, we can see a very clear kind of slice of a day in a life for this new API or this modified API that we've added or this background service or whatnot. And luckily, getting to that level of granularity or getting tracing from your code with OpenTelemetry is extremely easy. And more important than that, does not require any code changes, especially if you're using the Java agent. So there are other ways to do it, but the Java agent is the easiest one and especially suited for dev and test. We'll talk about production in a sec. But all you need to do is set an environment variable. We'll see that in a sec. Run your app. That's it. No code changes. Everything gets instrumented because of the support that OTel has. And immediately we can start seeing those insights and kind of understand better what our code is doing. There is also an alternative for Spring Boot, which is Micrometer tracing that requires a little bit more of a boilerplate. Give some examples later. But basically, it's much more performant and suited for production because it uses, less bytecode injection and reflection, all sorts of things. It just kind of uses native classes within Spring. So we'll go into all of that code in a second. But before I do that, I just want to talk a little bit about using this code or using this data. So I'm not sure how like you probably all have heard the term 10x developer or 10x engineer. I don't know how many of you had a chance to meet one. And I had a chance to meet a 10x engineer in potential. But before that, I want to tell you about what was supposed to be a 10x engineer and ended up not being one at all. So I had a guy in my team who was brilliant, really one of the most brilliant developers that I had a chance to work with. And he would just sit down, start coding. At a certain point, he just deleted everything, coded it again. Then he just deleted it again, coded it again, and then it was done. It was like perfect, no need to debug. It was as if he had a compiler in his head. I don't know how he did it. And his code was, pitch perfect. Only thing is, nobody could actually understand his code. Everything was almost naturally obfuscated or encrypted. And although on the surface, he seemed to be kind of just a definition of a 10x engineer, from a team productivity wise or moving the needle from the team perspective, he wasn't that at all. But then I want to give you another example. And this is a guy from my team who did something very strange. And what he did surprised me. He, at a certain point in time, I started noticing that our logs were extremely polluted with kind of console statements that were basically numbers. So I asked this engineer, like, what's up? Why are you spamming our, log and console messages with all of these numbers? And this developer told me, I'm working on this background service that does a lot of aggregation. And as I'm working, I'm really, really keen to understand if I had any regression, if I introduced some delays, or if I somehow affected, like I'm recording how long the entire kind of loop takes, and I want to know if I change something here. So I know in my mind that it should be between 40 to 60 millisecond. If I start seeing too many 140 or 200 numbers there, I know that it was me and that I caused an error. Now, this is a classic example of amazing intention, but using the wrong tools to do it, right? But at the same time, this is exactly the DNA of a 10x developer for me, because I had 14 developers in that team. They were all working on similar features. None of them actually had this idea or responsibility or ownership to the extent that it's not just writing code and releasing it. They wanted to understand the impact. And more interestingly, this developer wanted to see it as he was developing. He wasn't even, before we were talking about this use case where Bill is deploying into production and then he wants to see the effects of his code. This is much earlier in the process. And this got me thinking about the potential of the information that we can get from OpenTelemetry. And, development isn't linear. It's not a linear process. It's not just, develop, test, deploy, because the information is there all along. Think about it. As you're working, you're creating data that tells you stuff about your code. Before you even started developing, there is already a lot of knowledge about this code. Who is calling this code? What is the expected baseline for it? What are exceptions that I already know about? What are some bottlenecks? What are the weak spots? There's a lot of information there. And the problem is that often when you ask yourself, what do I actually know about my code? It's not a lot. Like the test can validate it functionally. Okay, great. They're also a bit problematic because they tend to be sometimes biased and steer towards the happy path. But at the same time, when I ask, what do I know about this code? And, especially true about generated code, if you're using any chat GPTs or other alternatives, understanding how this code works is really important. So the next thing I want to talk about is to leave the slides for a second, and let's look at the real example of a live project and how I can actually use OpenTelemetry when I'm developing. But before I do that, I'm going to just check if there are any questions about the topic so far.
Yeah, there's a couple things in the chat window. The user interface is cutting it off a little bit, but I think, oh, there we go. It's Dimitri was asking if the agent uses thread locals, and someone was responding, but I thought you might, I don't know if you wanted to chime in on that or not.
Yeah. I think it does use thread locals, but there is, like, by now, and I'm not sure about the exact kind of implementation, but from what I know, it's kind of a combination of things that the agent does, and the support within different libraries that have their own exporters that kind of add into what the that add their own information into the trace. And we'll see that in a sec, but basically many of the libraries, and I'm using like Kafka and Postgres and Mongo and other libraries, they all have their own exporters that kind of contribute to that same trace. Perfect.
Cool. Yeah. Ryan was elaborating and saying that it instruments Java util concurrent APIs and passes request context from parent threads to child's callable runnables on different threads.
And by the way, that's true. There are alternatives though. So
Yep.
for example, if you're using Quarkus and you're using the reactive kind of way, then the agent doesn't work that well, but they have their own extension towards OpenTelemetry that actually knows how to handle the whole kind of their own threading model and how to propagate the context if you're working reactively, so that you still keep a very you still keep the aggregation on each trace about any exceptions, issues, or just actions that we're taking in its context. So the agent is a great starting point because for most projects, Spring, Micronaut, Dropwiz, it will just work, and it will also instrument a lot of different things. But then for different frameworks, you might have to choose like a specific extension or different to use it. I know with
Ryan went on to say, and Dimitri, we're continuing to talk about his specific example is like Akka's actor framework. And so anyway, there's some additional detail in the notes.
And
you should probably check it out.
Yeah, and the agent does support Akka.
Yep. Cool. I just thought you want to know. So that's in the chat for you later when we're done with the presentation. There's some additional information there. Cool. Back to you, Ronnie.
Yeah. So, how can we use OpenTelemetry when we're developing? And in that sense, I think for me, tracing is a much more powerful tool than debugging. Now, don't get me wrong, debugging is great and you sometimes need to debug, but if you think about it, when you're debugging, you're forced to do several things. First of all, you need to know where you want to debug and catch that exact time when the problem is happening. B, it's a kind of a very localized leap between different breakpoints. And sometimes the important thing is not even in that specific instant, it's statistically across multiple requests. And then what do you do? And each time you look at a breakpoint, you kind of look at kind of a slice in time. And that's very powerful, but also very limiting, especially in distributed systems, especially when you're talking about performance, especially when you're talking about scale. So tracing provides a very unique way to get a lot of information about your code that is very distinct from debugging. So let's take a look at an example. And we're going to use only OSS and free toolings in this presentation entirely. I'm going to look at Jaeger, which is a great tool for tracing and looking at tracing, at Grafana open source, which we're going to use for dashboarding, and Prometheus that we're going to use to aggregate the metrics. So with that, let me leave the presentation for a second and talk about my example. So I had a long flight a while back, and I decided that it would be great to update the kind of go to Spring Boot example, which is the pet clinic, and add some more complexity to it and see what happens. So, pets have vaccination records, I guess. So I thought, well, let's create an API for vaccination records. So I went ahead and create like a component and a fake API that I put somewhere that actually can update the vaccination status for a pet, and it can get all of the vaccines. This uses OKHTTP behind the scenes, and then it actually takes all of the vaccines. It checks the vaccination status of the specific pet, and then it takes that information and it stores it somewhere so we can see if we need to kind of give our pet a vaccine. All in all, a very simple task. It required adding some business logic, database steps, updating the model, updating the view, but very small in scope, at least in this initial implementation. And I'm just about ready to check this in, and I can kind of show you how it looks. one thing that I did do throughout my development actually is I did that trivial step of adding the OTel agent. And in my run config, it just looks like this OTel resource, Java tool options, and then it has OpenTelemetry, Java agent, and I'm also using an extension to the agent. That's it. So didn't change any code, added this agent instrumentation. And when I run my code locally, right, I'm not even talking about the production use case yet. I'm just a developer running his code locally. And you can see when my code starts, there's actually a message that the Java agent is being used and my code is running. And I can go and actually go into the pet clinic example and I see, yes, it looks like it's running. And let me go ahead and trigger my code. And I did that before where I actually can go into, let's say, a specific owner and add a new pet. And this should trigger the code that I wrote that fetches the vaccination status. And all in all, it looks like the API that I created might be a bit on the slow side. So there's maybe a bit of a delay that I noticed. But all in all, it looks to be working. And I can also see like this new needs vaccine message that says false. I wrote some tests. They're all passing. I even use test containers. So it's time to go. It's time to check in my code. But at the same time, I was using OpenTelemetry to collect data. So I'm not as much in the dark about my code as I would be otherwise. Now, there are several types of data that I added. Let me show you just a few. So Jaeger is a tool that allows me to look at the tracing. It's very easy to start it as a Docker container. I'm going to share with you the Docker Compose that I use to start all of my services. But in this case, it just started Jaeger, Grafana, and a collector, which is kind of the OpenTelemetry component that allows me to route all of the observability data. So the collector is essentially a router. I can give it a YAML file that tells it, take all of the tracing, send them to Jaeger, takes all of the metrics, send them to Grafana, to Prometheus. I can kind of define what I want to do with the data and in a very easy kind of YAML file format. So with that out of the way, I can go and see what did all of these requests that I just performed, what do they look like? And immediately, I can see the latest requests. And this is great. So I want to look specifically at the post operation for adding a new pet, which is what I just did. And lo and behold, it looks like there's some errors there. I missed them, or maybe I swallowed them in my code. And also, when I start looking at the code, it looks like there's much more going on here than I thought previously. So again, if I were to debug, imagine, I would stop at a breakpoint, I would move to the next breakpoint, and I would not know what happened in the interim. Like I would not have a clear view of all of the processes that happened during the request. And this is something new. This is something that is, first of all, effortless for me to activate. I just added a few environment variables. I'm not checking anything into the code, and I'm not influencing production or any other systems, but already I'm getting a lot more information about what my code is doing. And this example, it might be a little bit maybe obvious, but surely something is wrong here. And you can see a lot of different HTTP requests going on here, and some of them are failing. So multiple issues start surfacing here. Now, we can also look at some metrics. So at the same time, one of the nice things is that, again, OpenTelemetry, this is Spring Boot, all of these things already exist. I don't need to create a dashboard or anything like that. So I just imported the usual dashboard or like the published dashboard for Spring Boot. And there's a lot of information here. I just added kind of enabled the actuator and some of these metrics in my code, and automatically I'm getting a lot of data. But specifically, I added some code to track the execution time for the specific API that I added. So this is looking at owners pet new, and I want to look at the kind of median request time, and immediately you can see, yeah, there is a problem here. This is what it took. This was the baseline. This is what it was kind of taking before, and this is how much it's taking now. So I can see a very big leap in terms of timelines as well. So all in all, it looks like there are a lot of regressions here, and I was just about to miss them as I was going to check in my code. But what else? What other regressions are there? And here's the rub. All of that information, in this case, yeah, something weird is going on with the HTTP code, with the HTTP. There are some errors here that I was somehow swallowing within my code. If I kind of dig a little deeper, I can see that, yeah, it's throttling, probably it's a 429 HTTP error. Things are happening here that if I were only to be able to, if I were able to analyze my traces, I would be able to get a lot of knowledge about my code and improve it. I would be able to not maybe commit specific mistakes as I roll it out. But at the same time, this is not happening. And going back to my original frustration, when I introduced this to the team and I gave Bill all of this knowledge and all of this access, and I gave him tracing, and I gave him metrics, and I gave him Jaeger and other tools, and even APMs, it didn't quite work. So still the next thing that the developer would do after checking in their code was 99% of the time basically move on to the next feature. And as they were working on their code, sometimes they would look at the tracing, sometimes they did not. Most likely they didn't. So you guys are all developers. What do you think is the reason, culturally, process-wise, technologically, that it does not happen? Why is everybody not doing continuous feedback? Why is everybody not actually using this data to improve and their code, to improve their coding practices? What do you think?
And folks, you can unmute yourself if you'd like to just jump in. So go right ahead if you're feeling inspired.
No real skin in the game. I like that answer. That's a good point. I sometimes think about kind of, why would I go searching for trouble, right? It's like, why would I ever want to go search around and tracing, and then maybe I could find an issue, and then I would actually have to fix it. Maybe it wasn't me that caused that issue. Needs infrastructure to be available before it can be utilized. I'm not sure I understand that. Samir, do you want to maybe explain what you mean by that? It's likely not a phone. Yeah, that's a great point. Samir says he cannot unmute. Can you help with him with that?
Yes, just a minute. It is set for everyone to unmute. I just double checked, but I'll see if I can do it manually. Hold on just a minute.
In the meantime, I'll just refer to the other, which is really important, which is...
I can speak now if you would like.
Oh yeah, go ahead, Samir.
Basically, it just seems like there's certain components that are required. So the barrier to entry, like you need an elastic data store, Kafka, Q, or whatever your endpoint is. And the other thing I would say is you'd need in a multi-service infrastructure, like you need the various developers to all buy into it. Otherwise, the value, I would say, is less so, if not all the components are also publishing telemetry.
Yeah, but I'm talking, that's a great point, but I'm talking about something much more trivial. What did I just do, right? I didn't, I could be running multiple services, but then I just enabled OpenTelemetry. I didn't have huge amounts of data I needed to store. I'm just running it in dev. And already I'm seeing interesting things. So, sometimes we look at the whole story. How can we get information from production and CI and testing and do this and do that? But I'm just kind of on the very basic level still. Why was I not able to take the data that, within 5 minutes, I was able to enable on my machine and, start in a container and get it? Why wasn't I not able to use it? And I think somebody here also mentioned something that's really important, which is it's not a part of CI. And I would just kind of take that a step further and say it's not continuous. And to me, the best example of something similar to that is testing, right? Because I remember the time where testing wasn't CI, it wasn't continuous, and nobody in their right mind would actually run their tests. Like it was, who pulls the short straw? Who gets stuck with the failed test that they now need to fix for everyone? So in the same manner, if the feedback doesn't come to me as a developer automatically, if it's not kind of an innate part of the way that we develop, it's kind of harder to make it work. Yeah, and I like all of the responses here, kind of the somebody else's problem, separation of responsibilities, needs to be implemented by all services. Yeah, but again, even if it needs to be implemented on all services, if I can run it, and we can see we can also enable it. I'll give her a link to how we can enable it in the same way without changing anything on like a Dockerized service, or you can have multiple components. Like enabling observability, that's no longer the problem. Like if you were thinking, yeah, I have this complex project, maybe it's hard to enable observability. I think OpenTelemetry has got us beyond the brink where this was a problem. At the same time, the problem is not solved about kind of how do we actually use it. So not being continuous is a huge gap. And beyond that, I think there are other matters. Yeah, Peter, you mentioned size and storage of volumes of the data, but I would just argue in this case, that's no excuse. I was running it locally. There is no huge amounts of data, and already I was seeing interesting things. So one thing is expertise, and expertise meaning, I just looked at a single trace, but I'm going to have hundreds, if not thousands, if not more traces running, kind of being recorded to start working through the statistics of what's an outlier, what's an anomaly, how does this usually behave? Is this abnormal? Requires me to refresh myself on statistics 101 and to be able to extrapolate the data from raw tracing. Like as an example trace, it's good. Sometimes it gives me information, but if I want to make it work at scale, I'm going to need some processing. Context switching is a huge one, like especially for developers. If I need yet another dashboard to check, there's kind of this dashboard fatigue where there's so many tools and dashboards that I need to know already. And if it takes me away from the coding, maybe it has kind of a marginal return sometimes, but again, think that it's a very reactive process. So imagine I'm the developer, I'm going into the trace and then I find nothing. And then the next time I roll my feature update, I'm going into the trace, I find nothing. At a certain point of time, I'm going to give up and not check the traces 90% of the times in hope of finding something important. Even though those 10% of the time where something important does exist in the traces or in the metrics or in the observability, it could be really important. Yeah, and not scope. That's George is mentioning that it's not a feature that adds value to the end users. And this is where I can put on my product manager's hat and say, yeah, you're right. We're not giving it priority because we're thinking in terms of roadmap. And this is how we create technical debt, right? So this is where my own kind of personal journey with observability started. So I was working in development in teams, in as a product manager, as a developer, multiple types of roles, and this was getting me to pull hairs out in frustration because of the gap. If there was no information, I would say, okay, well, we know what we know. It's hard to know more. What can we do? But the situation today is the information is right there, like observability, light years from where it was. We have OpenTelemetry. We have all of these technologies. It's there. The data is there. But then something is preventing developers from using that data. And that something is continuous feedback. Like if we don't have, as you yourself mentioned, if we don't have a CI type of kind of automation that will make it a part of my dev workflow, it ain't going to happen. So I want to show you what we're trying to do. How can we actually take the raw data and make it into something that I can process and make available to developers as they code? And in my mind, it's kind of like this intelligent agent that just sits on top of the observability going, is this important? Is this important? Is this important? Okay, this is important. I'm going to tell the developer about it. But just have that process happen automatically. So Digma is a project that we started that does just that. It's free. It's completely free for developers forever. You can run it on your work project. You can write it on your personal project. It doesn't cost anything. It's distributed through an IntelliJ plugin. So you do need to use IntelliJ, but either Community or Ultimate will work. And it's essentially local. So it doesn't even require you to send data anywhere that you don't want to. So I want to show you kind of the same experience. And this is the same project, kind of with the same toolings, only I'm going to use Digma behind the scenes and see what it can actually tell me about the code that I'm about to check in. So I'm going to just enable Digma, and it's just a plugin. You can find it in the IntelliJ marketplace. I'm going to enable it, and then of course I might need to restart the IDE. That will take a sec. And then I'm going to go back to that same view and maybe illustrate the experience that we're trying to create. And Digma is a young product. It just launched. But we are slowly kind of rolling in more and more features that do exactly that, what I was kind of mentioning before. So I'm going to kind of take that same type of action that I was showing you before. So again, this is a new feature. Only this time, to make it a little easier, we've simplified it to the extent that I can actually enable observability with a click, so that I don't need to worry about the agents and all of that crap. I just enable observability, and if it's Quarkus, we use the extension. If it is Spring Boot, we use Micrometer or the agent, again, depending on the policy that you enable. But kind of make that, just take that out of the way. No need to worry about that boilerplate. And once I've done that, I'm just running my process. It's using the agent behind the scenes. Let's kind of take that same action, add new pet. So we have some data. And yeah, we can definitely see the delay here. And once we've done that, and this completes, we can go back into the IDE, and we notice there is a green dot here, meaning that Digma is already picking up the observability that's happening here. And we can see, yeah, we're looking at this dev environment. And And we're seeing the APIs that were just triggered, and we're already seeing some issues that are associated with them. So let's start with that post request that we made and see what's going on there. So I clicked here, and if you can see, I'm going to actually make this a little bigger. You can see a lot of these things, as I mentioned, where I needed to kind of manually handpick and kind of analyze what the trace was doing were happening automatically behind the scenes because I had Digma kind of running analytics on top of the observability data that, again, was enabled just by clicking that toggle button. So first of all, there's an N+1 issue here that I did not notice. It's actually an inherent part of the pet clinic example. We created an issue to solve it. And we can already see, yeah, there's an excessive HTTP calls going on here. So again, immediately we have an understanding of how this function works. We can see the errors that we saw before that were hidden, and we can double click to see more information about them. And if I want to know more about, let's say, this N+1 issue, I can actually click and see where it is in the code. And I can see, yeah, it's happening in this repo, and it's actually affecting multiple endpoints, which is interesting. And I can look at what a trace looks like. But this time, it's not like I'm searching around blindly. Let me make this a little bigger. It's not like I'm searching around blindly looking for an example of an issue. I found the issue, and now it's showing me what that issue looks like. So we kind of inverted the pyramid. Instead of searching for trouble and traces and then and spending a lot of time analyzing it, we're already found the issue, and here is what it looks like. And yeah, this definitely looks like there's some too many selects going on here. And it's also completely mapped to the code. So I can click kind of and see, okay, this is the trace, this is where it is in the code, and I can continue my search there. So first of all, I can immediately see exactly what's going on. I can start from the action that happened, or just look at kind of the documentation for this specific piece of code and understand exactly what are the issues that we're seeing here. And these are issues that were essentially hidden from me before. And I can also see kind of a live view of exactly, okay, here's the duration uptick that happened. These are the metrics that we saw before, only again, it's something that's live, and Digma actually notices it, and it tells me, okay, where the bottlenecks are, where most of the time is being spent. This is the mock API HTTP calls up to 5 seconds, and so on. And I can look at other kind of requests that I've just made and see that there are other issues that I wasn't even noticing. So, for example, if I look at the when I modified the view in order to show the status of whether he needed a vaccine or not. And I can see that there is an open session and view issue here, where it was actually running, like during the rendering, it was making SQL calls because I was, accessing a lazy property, and Hibernate was kind of doing its magic thing. And unfortunately, during rendering, it was triggering SQL queries. And again, something that I can see an example of very quickly. And I'm just showing that to illustrate how very easily, just by kind of analyzing the data that was already there, we can already have this extra layer of insights about the code that appears automatically. That's kind of a living documentation of how this code behave, and that I can actually use to notice these things and improve my code. And there are even more complex things that we can notice when we start importing in data from production. That's where we can, or testing, that's where we notice scaling issues and kind of see how the code behaves between different environments and so on. But the main thing is that we took something that was very disjoint from the code, observability as a concept, yeah, and there are traces and metrics, but it essentially references the code. So we've, by tying them together, understanding and running a lot of some machine learning, some data science, some basic statistics, we're able to find the anomalies, find kind of what I should be paying attention to, and basically bring that into my view as a developer, as I'm writing the code so that I know to address it. And this is what we're trying to do with Stigma. Basically, we're trying to create this experience where I can actually take all of that data from OpenTelemetry and not just leave it there as a science project, not create nice dashboards, but actually take that information back into improving the code, which is the goal, right? The goal is not effective observability. The goal is better coding. And with that, let me, I see there are some questions. So before I move on, I want to make sure that I answer them. Let's see. Although Micronaut supports OpenTelemetry, can you confirm that Digma supports? Yeah, it does support Micronaut out of the box. It'd be nice if there was an OSS free tooling for open tracing like we have these days for CI/CD. So what do you mean open tracing OSS free tooling? Like Jaeger is open source, for example, and Digma is free. So do you mean like a tool to accomplish anything else, Samir? Can't unmute again. Not sure why. Okay. While we try to
Okay.
unmute.
Sorry. So I guess like for CI/CD, it's become so common. Like you have Travis CI, GitHub Actions, GitLab.
Oh, got it.
Several options for that. I don't know if any like hosted tool that will allow me to publish, for example, telemetry and be able to look at open tracing.
Yeah, it's that's like enabling tracing in your CI/CD is trivial. Like it would be interesting to have a GitHub action, but basically it's just adding the same environment variables, like for if you're using the agent, like for Java tools, and then specifying the agent and maybe some parameters about where you want to send the data. Having a hosted service is interesting, depending on where you want to send the data to. I'm guessing there are some alternatives there. I'm not sure if they're free and definitely not open source. But it's a good point. Thanks for the question. Sean is asking, looking at a Digma site, I don't see an explicit confirmation. Yeah, this is IntelliJ only. Unfortunately, just because it's the first release, but we already have some plans towards VS Code as well as Eclipse, so it's kind of just a matter of time. It's not a big deal. What was causing the excessive SQL select queries activity in the UI? Yeah, it was bad modeling on the Hibernate part. It's a problem in the, not sure if it's bad, it's just not optimized. In the pet clinic example, basically Hibernate is lazy by default, and the code was accessing a property on one of the lazy relationships, and that was just causing the select n+1. And does it support languages other than Java, frontends or fronting services? So Java is what we started with. Next is going to be Kotlin, because it's easy to make the transition, and also it's a cool language. And after that, we will see kind of what's next. But we really wanted to create a really good experience for Java that's also kind of looking at specific insights and things that Java developers would find useful before we think about other languages. Part of that was just because the amazing community and how people in the Java community really like to provide feedback and to help build a better experience for developers. So we got a lot of support and help from the community. And this kind of just made us, invest even more in kind of in Java first.
A lot of people write backends in Java too, that's certainly a thing.
Yeah, for sure. Now, as I mentioned, Digma is completely free. So, go ahead and you're very welcome to check it out. We're very much interested in hearing your feedback. So I'm going to include in a sec an invite to our beta program, and it might sound weird, like it's already there. Why is there a beta? But our beta program is really like, I believe products should always have like a beta, and what the beta program is just, if in addition to just using Digma, you're interested in providing feedback and helping us build it and maybe contribute to some of the open source libraries that we're adding, then that would be a great kind of opportunity. And what it means in practicality is that you just give us more information, and we have some sessions and video and Zooms where we can kind of drill into what you would find interesting and kind of get your feedback on what was terrible, what was good. And this is also a lot of feedback to rely on. And from your perspective, we give a lot more information about kind of how we use OpenTelemetry and get maybe a little bit more involved in some of the design of the feature. So not for everyone, but if you are interested in contributing towards that, I just pasted a link in the chat towards the Digma beta. So it's either you can just install Digma on your IDE, again, running locally. It's just a plugin in the IntelliJ marketplace, and play around with it. It will allow you to enable OpenTelemetry without making code changes. No prior OpenTelemetry references or support is required. Like, you don't need to take it to a project that already has OpenTelemetry. You can take it to a project that has zero OpenTelemetry, and then just Digma will use the agent behind the scenes to instrument it in runtime without changing any files, and then analyze it and give you back information. Yeah. I think somebody wanted to ask something. Yeah, I'm sorry. I added the beta link on a direct message by mistake. So.
And my apologies, folks. I'm not really sure why it's happening, but I'm looking at the Zoom user interface, and it's I think I have allowed participants to unmute themselves, so I might have misclicked. If it's not working, just ask to unmute in the chat, but I think I just fixed it. Apologies for that.
If I may, I have a few questions, Ronnie. Thank you for the presentation. So, quick question. Does your plugin currently analyze outgoing calls to other REST services?
Yeah.
So what you demonstrated incoming call, right?
So the specific insight that you saw was about outgoing calls. So basically, oh, sorry, let me share this again. But basically, when we looked at the insight that was actually telling us there were too many HTTP calls going on,
Okay.
it was actually analyzing, the excessive HTTP calls were made to the like specifically to the mock API HTTP, and we can actually go there and see this is kind of the that specific call.
Okay, then next quick question. Do you have plans in your roadmap? Cassandra, gRPC, reactive WebSockets?
Within Java?
Yes.
Those are already supported within.
Okay, thank you. Thank you.
Yeah, anybody feel free to ask any questions, and go ahead, Dimitri.
Right. So this question is both about OpenTelemetry and Digma. So question is, when we use OpenTelemetry to do the tracing across different nodes, across different services, does it just do the correlation between the request, or is it capable of collecting more context for the calls? Like, I don't know, the caller IP, the various headers, stuff like that, and consequently, does Digma do anything with that extra information if it's available?
Okay, cool. Yeah, that's a great question. So OpenTelemetry has the concept of basically attributes or tags that you can add to the span. And by default, you can see many frameworks are already kind of adding some information there, but it's something that you can customize. So for example, if I were to look at our example here, let's take a look at one of the requests. And sorry, I like this a little bigger so that you can see. We can see, for example, that this specific post request was recorded by Spring, and make it. Yeah, and we can see some information was already added here. So like the HTTP route, HTTP target, host port, address, OTA library name. All sorts of information that was added just by default by the what is called an instrumentation library, or the library that was providing that information. And there is also, this is structured data, and there is what is known as semantic convention. So there are these names like HTTP method, HTTP route, or whatnot, are all kind of standardized. In the same way, if I look at a specific, let's say, select, I can look at the DB statement, and I can actually see, okay, this is the DB statement that was run by this select. So I can go all the way to specific kind of attributes that tell me like the database name, connection string, and so on. And I can add my own tags, which is really interesting. Now, so the short answer is, there are things that come out of the box, and it's also possible to extend, of course, and to add your own tags into the span or into the either by adding some sort of an configuration of your own, or kind of adding it to the span, or intercepting on various levels. Now, with that data, there is a lot that can be done. So some of what Digma is doing is analyzing patterns. So for example, are most of their requests that are slow accessing a particular database? Are they accessing a particular table in the database? All sorts of things that we can aggregate and kind of discern by looking at how these tags correlate at scale. So this is a very interesting problem, because a lot of times when you move outside of a specific trace and start looking at how the system behaves as a whole, you're starting to see these patterns. All of the threads that have exceptions are running on a specific machine. So maybe something is wrong there. All sorts of things that kind of don't present themselves very easily when you're looking at individual traces, but you do start to see these patterns when you look at the traces as a whole.
This is extremely cool. Thank you.
Cool. Amazing. So if anyone has more questions, feel free to speak out or have them into the chat. I'll be very happy to kind of answer any other questions later on. So best way to reach me, I'm just going to put here in the chat, is either on Twitter, where my handle is Doppelware, or this is kind of my email address if you want to reach me. But in general, kind of, I'm going to send a few more links that will probably be included in the YouTube video. And that's going to be the stack that I used to start the observability toolings, except like Digma already includes Jaeger and some other things, so you don't need to install anything. But if you don't want to use Digma, you just want to use some of the other tools, I have this Docker Compose file that already sets everything up for that. And then there are some additional documentations about how to enable OpenTelemetry and things like that that may be useful for anybody who's interested. So there are some resources, and of course, the link to this own project where my own kind of terrible attempts at adding a feature that ended badly with all of that code. I see another question. Is there any way to integrate with API file-based tests? Yeah, that would happen automatically. Like if you run an HTTP file, that would trigger the endpoint that would be instrumented by OpenTelemetry, and you would see that information appear. So that would just happen. And in general, like I'm using test containers and to run some tests as well. And these also get instrumented automatically. So those also give me a lot of data just by merit of running them. And that's a whole different discussion about how OpenTelemetry can actually allow us to get more of our integration tests than we may have done before. So it's not, by running the test, you're getting not just pass-fail, you're getting a lot of other types of data about your code. So I'd like to thank everyone for participating and listening to this kind of overview. I'm very, very kind of keen to hear more from all of you. If you happen to use observability more, if you're thinking about continuous feedback and how to implement it in your where you work, or if you do try out Digma and you find something was terrible, something was great, or something was meh, just let me know. These are all really, really important for us to know, because we're trying to create the best dev tool possible for this.